So as you can see, we already took it apart. The good news is that we fixed it and the car is running, and in this video I'm going to show you, I'm going to go over the little details and the troubleshooting steps we did in order to find what was wrong. After I disassembled it, I took all that glue out between the boards. Here's what we have inside. So this is the top part where the heatsink goes. The heatsink, this heatsink, and there's another heatsink, and then the fan on top like this, and then this cover right here. So it's all taken apart. This is the top view of it, and this is the second board that was like a sandwich like this. Okay, so I just want to say before I start this video, I want to say that I am not a professional in any way. I did not finish any courses or college of microelectronics or soldering or anything like that. So all this that I'm showing you was everything was a guidance from my brother. He was telling me on what to test, how to test. I used basically this microscope with the live feed on my phone. There you go. Just like that, and we checked everything, and then I used my voltmeter. So basically what we did, he told me to look at the board and check any visual, if there's any elements that are busted, burnt, or melted, and so on. So at first I looked at it and I didn't see anything wrong with it. All the elements look very good, nothing burnt, nothing melted, nothing like that. So the main reason was in the instruction, there's a little LED right here that's supposed to light up when you turn the switch on. So when you turn the switch on, of course, when everything is connected and all that. So I had a longer wires connected to both boards just the way it was. Right now it's a small wires because this is the end part. I'm just gonna solder them where they're supposed to go, and we're gonna make it back as a little sandwich like that. This is the final piece of art that we did. So visually, like I said, there was no problem. There was no burnt elements, nothing like that. And so I took a lot of pictures. I sent it to my brother and he got back to me. So I guess all these are MOSFETs, and on this side under this heat sinks are also MOSFETs. So if there's my brother said no visual, if there's anything damaged, then leave them alone if they look good. Also, he told me to check all the soldering on the board to make sure nothing is bridged or anything like that. So everything seemed to be fine. The first thing he said when he saw the pictures is to connect the battery and check the voltage. Basically, this is where you would connect the battery on this end. So our troubleshooting lasted about 3 weeks. We did a couple hours, 2 hours a day, a few times a week. So every time we did it, we connected the battery to this end, and we checked if there's voltage coming into the board. All right, the next thing we checked is if there's voltage at the power button. So this is the power switch, it turns on and off. So we checked there's voltage coming in. We checked the voltage that goes from this wire. This is the one that connects to a receiver or transmitter on the car. So we were getting voltage here, everything was working properly. And as my brother looked at the board, the first thing we did is we looked on this side. So this side, the way he explained me, we looked at the major big chips, right? So the first one was this chip, and then we have another one here, and then we have another one here. So what we did under microscope, we looked at the part number of this chip. So I just used my microscope. So once we found the model, we searched all 3 models from this chip, and we found MP2908A. We Google it and we search for the data sheet. And here I have the data sheet right here. We found the data sheet using Google search, and we searched for MP2908A. We found the data sheet. It's a PDF. We downloaded, and the next thing my brother analyzed the schematics. So what we were looking for is every pin, what it means. So we were mostly looking for the voltage that comes in at what pin. So we have in voltage at pin 1, and then we have something at pin 3 and 4, and all this you know, this abbreviations, you can find them. There's a table. It should be in the data sheet. There's always a table that will tell you all those abbreviation, what they mean. So we basically looked at the input voltage, and the output voltage is SW, as you can see here, SW, output voltage, V out, under 24 volts. Anyways, let's go back here to our microscope. Under microscope like this, I did not know, but my brother explained me. So you see, every big chip like this will have a circle engraved into on one of the corners, on one of the four corners. So where you see that circle, it could be a dot like engraved in. So that's the pin number 1. Let me switch my hands. I think the light is being blocked. There you go. And so what we did, so from this circle, that's where pin 1 starts, right here on the left, and then it goes 2, 3, 4, 5, 6, 7, 8. So we checked the input voltage on pin 1 and the VCC1 on pin 4 and VCC2 on pin 3, and then we also checked on pin what's that, SW, pin 18 on this side. We checked the voltage that goes out. So this chip was getting voltage and was the voltage that goes, the output voltage was all good. Then since this chip was getting voltage and it was supplying voltage out to other elements, we assumed it's a working chip. And then we moved to the next chip, was this one, CF330B0OFB1718 plus. This is a very small chip. We did the same thing. We looked for the data sheet. Now let's go back here to my Raspberry. So let's close this one. So this is the CF330. It's very hard to find these chips because they have a different model number when you Google them, but it's not very hard to find them. So here's the chip, this CF330. So in this chip, it has 5 pins on each side of the chip, and the most important are on this side, P00 ground, VDD, that's the voltage, and everything else we really don't care. We just want to know if voltage gets supplied to this chip. So same thing, this circle dot right here means this is pin number 1. So this particular chip is supposed to get, let's see, where's the voltage, 3.70. So on 2 and 3, when we use our voltmeter, we need to get 3.7. So we did the same thing. We went back here to our microscope, and we checked pin number. So here's the little circle right here. So that means on this left side is pin number 1, which is P00. We don't care about that. Pin number 2 is the ground. So what I did, I used my voltmeter, the black end of my voltmeter, I put it on the ground, basically on the negative that comes from the power battery, from the battery pack. And then I checked on the resistance. If it showed 0.0, that means there is a connection between ground and ground. And the next thing, I checked between ground and pin number 3, and this chip was getting 3.7 volts. And we assume that this chip is working, assuming it's working, because the ground is connected to the ground and we're getting 3.7 volts. So this chip must be working. And then we move to the third chip on this board, is this one. It's what is it? Fortior FD6288T, and then the last numbers are EC8037. So we searched this guy, but unfortunately we couldn't find too much on the internet other than what was this? This was a something written in Chinese or whatsoever, but we were able to find this the pins and their names. So as you can see, we don't really know what's all this means, but we only care about the COM on pin number 8, which is the ground, and the VCC, and that's the voltage that supplies this chip, is on pin number 7. So we mostly looked if there's voltage coming into this chip. If it gets a supply of voltage, that means it should be working. And I don't understand what is all this, but I'm assuming that FD6287 and ours is, let's see again here, 88. So 6288, it's supposed to get VCC should be 6.4/6 volts. So this chip gets 6 volts and the ground. So this is the only data sheet we found. There's nothing else. So it was very hard to work with that data sheet as it gives little information. But anyways, with the microscope, we were able to see this circle right here. Well, I was able to see it, and I counted pin number 1. So there's I believe 10 pins in this line, and then the 7th and the 8th. So with the voltmeter, I check if the ground pin is connected to the ground, and it was. And then we checked if pin number 7 gets any voltage at all. So with the voltmeter, where one end was on the ground, on the negative and ground, and then with the voltmeter, the red lead, I put on this pin, and we were getting 0 volts. So basically this chip was not getting any power voltage, nothing at all. So this is where we start looking backwards. Where is this chip getting power? So what my brother made me do is, since we couldn't find any schematics of this entire board anywhere on the internet, my brother decided to make me draw a schematic myself. So basically we started with this. So we had the first chip we checked, the SEAL F330, and this one. And so we were looking at pin number 7 that was not getting power, and we were tracing back this pin number 7 on the board with which elements are connected. So I used my voltmeter basically on resistance mode, and I would put one lead on pin number 7 positive and see with what element is connected. So I found that this pin 7 is connected with this little element, and then with this one, and then with this little there's a hole here. That's a hole that goes on the other side of the board, that goes on this side of the board. So it goes somewhere in here, one of this. Let me see, am I right? Yeah. So it's one of these little holes right here. So that means the voltage goes to that chip from this side. So basically I use my voltmeter and I draw a schematic of that voltage. So we traced it back. So we traced it back, as you can see. I drove, here's the UTC that makes from 12 volts, 5 volts, and then it goes on. And this was a chip 86287Y. Anyways, I drew these schematics using my voltmeter and this side of the board right here. I don't know if I can make it small and show you. Okay, let's do it here. Let's focus. There we go. So that little chip gets voltage on this side, right? So when my brother looked at this side, this is the element that makes from 12 volts 5 volts, right? So when we checked this element, this element was getting 5 volts, but was getting 12 volts, but was not making 5 volts. So this was this one right here is a replacement. We already changed it. The original one, I have it right here. So this was not making from 12 5 volts. And let me put it on the Let me put it on the microscope. So if you look at it, it's not burned. There's nothing wrong with it. It's not melted or anything, but it was faulty. It was not doing from 12 volts, 5 volts. So this is the first thing we did. We replaced it. So this one is the old one. We replaced it. I found on some of my salvage boards one of this, and here it is. It's UTC 7800. So we checked this one. We started back on the board and we measured, and it was getting 12 volts and it was giving 5 volts back on this end right here. Then we checked this yellow one. It was good. The next element. So as we went through this board, according to this schematics that I drew, so first, after we replaced the 5 volts, we went back and we checked, okay, here I have it. We checked the 7th pin on that 40-or chip if it's getting power, and it was getting 4.9 volts after we replaced that this UTC that makes from 12 to 5, but 4.9 volts when we connected this board back to the car, it was still not running. The car was not driving forward and reverse at all. So we came back here on the under microscope and we looked more on this schematics, and as we went forward, that 40-or chip, it's supposed to get 6.4 to 6 volts according to the data sheet. And when we went checking, we found this chip right here, 86287Y. He was getting 5 volts, but he was not, the output was not 5.8, it was not 6.4. Anyways, it was 4.9. So this was our main area of concern, that it was getting 5 volts, but it was not making that supposed to get 6.4 or 6 volts. So basically this chip 40 or right here, and this chip right here, let's see. This one, yep. This chip, it was getting 4.9 volts, which is not enough to power it up, since on the data sheet it's 6.46 volts. So the chip that was not making, it was right here. You can see 1, 2, 3 pins and 3 pins on this side, so 6 pins total. The 5 volts was coming this way into pin number 5, and then into pin number 1 right here under the red wire. We're supposed to get 6 or 6.4 volts. So the first thing is, when we found this chip was not making 6 volts, we connected to the power, and when we touched it with the finger, it was overheating. Like I could feel a very hot, and it was like 1 second hot, and then 1 second it was cooling down, then 1 second hot. So what we did, let me show you guys this chip. So this chip is, let me see, I think it's this one right here. Come on, in the microscope, there it is. So we have here, let me turn it around a little bit. So this chip is B6287Y, and let's see if we can find the data sheet. I have it somewhere. So we did the same thing. We looked for the data sheet on Google. Let's close this one. Let's close this one. The chip number was B6287, but after a lot of Googling, we found out that the actual brand chip name is MT3608, which is a high efficiency 2 amp step up converter. And here is the right here on the bottom, this is the schematics, and this is exactly where I made my own schematics. And when we looked at this one and we looked at what's here, it was exactly the same thing. So this one, it gets those 5 volts right here, 5 volts, as we're coming from our chip UTC-7800, so it's getting 5 volts, and depending on the resistor R1 and R2, it was giving voltage output. And in our case, it's supposed to be 6.4 or 6 volts, because that was the chip 40 requirement. The replacement, we actually replaced it with a chip that we had salvaged from one of my parts. So this chip we assumed it was the problem. This was the original that was on the board. So we replaced it with this one right here. So this one is a B6287. Yeah. So we replaced it with this one. I salvaged it from one of my boards. We placed it back in place. We removed the old one. We put the other one that we got. I soldered it back in here. We test the boards. Everything seemed to be working, but as soon as we plugged in the power here and we turned on the switch, as soon as I turned it on, I was holding my finger on this elements to see which one was getting hot. So this UTC-7800, it wasn't getting that hot anymore because we replaced it since it was faulty. But this one that we put here, right here, this B628, we replaced, and that one got hot right away. So basically we assumed that it was burned right away because it was getting very hot. And we tried multiple times, and we checked the voltage. It was only giving less than 4 volts, so it was not enough for our chip on this side to start up this chip right here, because this is the chip we're not getting voltage on, basically. So we went back on this side and we took out that chip right here. We took it out, and then my brother, we were very disappointed that we replaced another chip and it got burnt again because of something on this board is drawing too much power, and that's why it got burned. So then my brother got back to me, and he said, that this chip right here, this 40, is supposed to get 6 volts, 6.4. So he told me with the voltmeter, look where else on this board we can get 6 volts from. So I checked with the voltmeter in many places, like especially where this these pins are connected here, or on this board, or on this board. Basically we looked everywhere, and we found that 6 volts is supplied to this jumper that connects to the transmitter on the car. So there's black is the ground, red is the one that has 6 volts, and white is the 12 volts. So what we did is we looked at the schematics that I drew. Where's the output that needs to go to that 4th chip on the 7th pin. So basically the output, the main little wire that needs to go to that chip is after the diode and after this element. Let me show you here. Maybe I'll do it on the microscope. Alright, so the 7th pin gets power through one of these little holes right here that's connected to this diode right here, to this capacitor, and with this diode right here. So we basically needed to find 6 volts somewhere else on the board and supply it straight here. So I soldered the wire to this capacitor, that these elements are connected, this diode, this capacitor, and this small little resistor right here, and they all go in here into this little hole. So I soldered 6 volts with this red wire onto this capacitor, and that 6 volt wire that supplies comes all the way from here, from this red wire, and this is the that connects to the transmitter board on the car. So once we connect this 6 volt wire, we again connected the battery back here, and we checked with the voltmeter all the voltage, that so we were getting 6.02 volts. So this is exactly what we needed for this chip to work. Of course, we were not sure if this chip is still it actually works, but there's no visual damage. There's no 2-pin connected or bad soldering or cracked soldering or anything like that. And on this side though, on this side right here, where this chip was getting burnt, the first one when we got the car was burned, the second one we replaced was burned. So my brother told me to desolder every element, well, except this 220, and this is just a wire that I removed. This one I checked this resistor, this capacitor, I checked this capacitor, I checked this one, so they're all good. I didn't end up not removing these resistors and these two capacitors. We assume they're working. So when we supply the 6 volts straight here, of course it was an assumption that everything will work fine. Thank God nothing blew up, nothing else burned, and we connected to the car, and as soon as I pressed the throttle button, the car moved. So it was a relief. It was a very big relief, because this ESC runs about $50 to $80 depending where you buy it. So plus for me this is a very good it was like I was taking class of microelectronics. I learned so many things. I learned how to solder better. I learned how to check and what elements are what, and it's just a whole new world opened up. The reason why I still have it open like this, because I wanted to make this video and just show you guys, at least you might not attempt to open an ESC since it's waterproof. I'll tell you honestly, it was really hard to get all that cement glue out. I had to use my heat gun and scrape piece by piece out, but I mean it's a relief once we found what was wrong. I mean, and many thanks goes to my brother, because he had the patience to be like, hey, we need to do this, let's check this. So I would wake up 1 hour in the morning and do this before I go to work, and then I'll come home after my work and do another 1 hour checking everything, every element, and looking under the microscope to make sure all the solders are good. And he'll like check this and check that, and look at this paper. I drew schematics almost every chip. Look at this. We're checking the input, the output, 3 volts. So we checked every little chip that has more than 4 little pins. So like on this side, we checked this chip right here. Most of the chips that have more than 4 pins, like 6 pins or 5 or more, so we checked this chip right here was working, was getting voltage in and out according to the data sheet. And this one, very complicated. It was frustrating at some times that the letters and the numbers on these chips were not as the brand chip. So my brother had to like do a lot of research and try to assume that this chip is a replacement of the brand name chip, which is a different and has a different numbers and letters on it. But anyways, all in all, it was a little bit of hard times, because this board doesn't even have a number. This board doesn't have a data sheet or anything like that. So it was very frustrating, very complicated work. I didn't have the microscope, so I needed that. It's actually really good. You can even make a very close small element. I don't want to adjust the focus because I still have to solder this wire. So very happy right now. This is still we're still this in the troubleshooting mode. So I'm gonna solder this wires right here to these pins on this side, and it's all basically gonna be like this. We still have to find a way to see how we're gonna make this in the future waterproof. I mean, of course, at any given point you can spend $70 and buy that new ESC, but it's fun. I guess it's fun. I guess it's something that I was intrigued by to fix this and thank God it's working with a lot of help from my brother, which I'm very thankful and happy that he was able to guide me and help me. I'm gonna finish soldering this wires and we're gonna hook it up to the car. I want you guys to see that. Alright, so here we have the car. I got my battery already here and we got our ESC. Okay, here I have the remote and let's just double check everything is connected. We got this one, we got the power switch, we got these three, and these wires are all with shrink tube. Nothing is touching anything. Alright, so let's turn it on. The first thing we should hear is the fan. Let's move on this side. We should hear the fan and the LED. So my remote control is off. So let's turn this on. Okay, the fan is working and here you see the LED is blinking. That never happened when when I received the car in the mail. That did not happen. So let's put the car on the floor. I turn on my remote. Yep. So it steers left and right. And now let's give it a go. Ooh. Channel 2. Let's reverse the other way. So I want the throttle when I push down. Yes, the car is driving. Look at that. Woohoo! It's working, guys. Oh my god, this is amazing. Oh my god, I can't wait to take it outside. Whoops. Whoops. That was very fast. Oh my god. Almost hit the camera. Whoops. Alright. That's it for now. It's working. I'll take it outside for a test ride, but first me and my brother, we need to consult and see what are we gonna do with this board. It's not good to be exposed like this. I wonder what's the temperature in here. And those MOSFETs. You know what? Let me get my voltmeter. Has a temperature and measure. My voltmeter can measure the temperature. So let's see. The first chips on this blue board are 33 Celsius. The Seal F330 has 36. The fourth here, the one that was not getting voltage, is also almost 36. Let's see the MOSFETs inside. Well, the MOSFETs are, what, 34? So it's not very, very hot. Let's see on this side. So some of the MOSFETs are 40, 39, 37. Is anything hotter? 40 Celsius. Let's see on this side of the board. Is anything heating up? No, we got the blue board. This first board is about 30. This one is a little hotter. What about the heat sink? Let me see. Here's the heat sink on this side. 35. Yeah, 35. So it's pretty, it's not very hot. Yeah, this is very cool. I'm so happy this car is working. Oh my god. Can't wait to take it outside for a test ride. This is amazing, guys. We want to make it, the way it was, so we can waterproof it again, make it an enclosure, so we can take it outside and see how fast can it go. And I really want to see it in two wheels accelerating, and maybe on some rougher terrain to test this car out. So please, guys, comment below, let me know what you guys think. Thank you guys for watching, and this car looks very good built, and I hope I'm gonna enjoy it. I'm planning to put I have a 360-degree camera. I'll put it on top, and I'll get some videos later on. Alright guys, thanks for watching. Please like, comment, subscribe if you didn't so far. And many thanks goes to my brother for helping me figure out this. It was quite a long project. So thank you guys. Bye bye.